This one. Okay. I think we're going. Okay. Okay. So basically, what I'm going to talk about today is data management basics with SPSS and tax. So I'm going to talk a little bit about planning data entry and some documentation of data management procedures in SPSS, and then I'm going to talk a lot about SPS commands and how to use them to manipulate the data or to get what the answers to questions that you're looking for with your data, with your SPS commands. Okay. So, what is data management? So, basically, that's an official definition that I found, but think of it as basically you are trying to clean and sort of make the data be the best data that it can be. You have to do that. So kind of so using this just to kind of look and see where errors in the data might be, or where things are missing, or where things are talking where they shouldn't be, basically. Okay. So data management is important at all points in the project, from when you're initially starting to the end when you're thinking about where will my data be and who's going to want to access it 6 years down the road. So it's something you want to think about at all points in time. But today, I'm going to focus on kind of like the time after you have your data until when you will, until like, I'm going to do a little bit of simple data analysis. Basically, it's like that time period after you have your data before it's like going to move into like major data analysis. Okay. All right. So, talking a little bit about data entry planning, and part of the reason why I'm talking about it is because the way that you do the data entry affects your data files and affects your management of the data later. So there are a couple different options for entering data. You can use a scanning program like Teleform. You could use user assessive direct entry program like Qualtrics. There are data entry programs that you can purchase that aren't something that people really use here very much. At OSLC, we had a program called DE Keys that is designed for data entry, so you could use a program like that. You can do entry into a spreadsheet like an Excel or an SPS spreadsheet, or you can do entry into some sort of a database, like an Access database or another database that you might have. And does anyone know of any other options for data entry? I can't think of any either. So when you're thinking about planning data entry, there's a couple of things that you want to think about. First one is kind of access to your files, the program or the application that you're using, both for getting your data in and getting your data out. How many people here are familiar with the Qualtrics program? Yeah, so most people. So that's a program that is pretty easy to, so it's a web-based program, so it's pretty easy to enter data in and get data out. It's pretty simple. I can do it from this computer, I can do it at home, I can do it anywhere. So that would be sort of like a pretty low bar. And the thing that's good about that is that a lot of people can access it at one time. If you have a lot of, you have like a lot of data entry that you want to get done in a short period of time, that can happen. Whereas something like if you were entering directly into an SPSS file, that's a difficult program. You have to, everyone has to have a license, which is difficult, and only one person can be in the file at a time. So those are things that you want to think about. But if you're planning to do your data in Qualtrics or another database or another program like that, you'd want to see what formats can you extract your data out into. And Qualtrics is pretty good. You can do the CSVs or Excel files or an SAV file. So that's the straight SPSS file. if you're designing like an Excel or an Access data entry sheet, you want to design it to reduce errors. So if you have paper forms, matching it to your paper forms as much as possible, using visuals to reduce errors. And you can use a double entry system if possible, which isn't used here super a lot, but it's something that is kind of standard at OSLC. And so a double entry system can look like this. This is an example of a double entry system. So the person comes in to enter the data, and they kind of enter it along here. And then you can check. So you would have two data entry files, and you can either copy and paste over, or you can have people enter. You can manually go in and switch what you're hiding, so that you can check and see, and it will tell you the first person's entry and when it doesn't match the second person's entry. So that's kind of like an example of a double entry system. Does that make sense? Let me know if you have any questions.
Okay. Sarah, Jade, could you explain why that's done? The double entry system. Just so people have a sense of why it's done twice.
Sure, yeah. I mean, generally it's done for the accuracy. And I don't know how, I mean, we did that was, that piece that I showed you was from a SIBS form that we had that had a lot of, it's just a really difficult form to enter, so we created a double entry system, and there were a fair number of errors when I checked the two pieces together in it, but it kind of depends on what your form looks like and how difficult it is. If it's a difficult form, it's probably more important to be double checking your accuracy. It just kind of depends.
If this doesn't take too long, like how did you make the unhide so that it's, you were clicking and it was hiding and unhiding a bunch of columns at once? Was that right or not?
Oh, you mean, so,
In Excel.
yeah, sure. So it's, it's just hiding the whole sheet.
Oh, okay.
Yeah, so you can hide the whole sheet so that when someone goes in, this is what they see, and so they're like, I'm going to do my data entry, I'm going to enter my people.
So one person has one sheet and another person has a different sheet, and then there's a third sheet that will compare them?
Yeah. Yeah. And so then you just tell, you know, if this, what's in this sheet and that sheet in column D5 and column D5 are not exactly the same, you want it to give you that error message.
Cool, thank you.
And you can use that, yeah, we're not talking about Excel today, but you can use that for data entry, and I've also used that sometimes when I'm just comparing things, when I think they're going to be the same in Excel, and then they're not always the same. It gives me an error message. You can also have it say something nicer than error if you want to. You really have to say error. Very nice thing. Puppies and kittens are okay, oh wait, here. Okay. So if you're designing a data entry sheet of Excel or SPSS, so you want to have a number of code for each person or form. So if you're doing like an anonymous survey, like something that's like more anonymous, you might have an anonymous survey, you want to take each form and give it like a unique number or code, so that if you're looking at the data and there's a problem, you can go back to that. You can say, oh, I don't understand what's going on here, so I can figure out which form that is. So this is person 15, and go back and physically look at the form to make sure that you can have a reference to go back. And so you want to design your data to always have, each row is going to be a case, which could be a person or a time point or what have you. And each column is going to be each column is one variable with one piece of data in it. And that, we'll talk more about that later. You can divide things like date into month, day, and year if that makes sense. Sometimes there are situations where you might know the year but not know the month and day, and then that way you can have more information. And it just sort of depends on your situation. Sometimes with ages, you might, depending on your situation, you might know the year and you might be able to use that later. Whereas if you have a date, you don't have a full date, you don't have any information. You know, just enter the pieces that you have. Using numbers if possible instead of text. We'll go into that later. And then we can cover doing the data entry sheet in the SPSS later. Okay, so talk a little bit about documenting data management procedures. So when you're in SPSS, or in general, you want to document as much as possible. Document some more. I think, you know, I've never really had a time where I thought there's too much documentation, but I've certainly had times where I'm like, what was I doing? It was 3 months ago, but I don't know. And also for other people coming in and looking at your work. So you want to be clear what you did and a reasonable amount of why you did that, what you were thinking, why that was making sense at that moment. Because again, you'll come back 3 months and go, what was going on? I don't know. You want your syntax to be reproducible, so someone else can run your syntax and get the same results. Or if there's some data update or modification, they can get updated results. So if one of your assessors leaves and come in the next morning and they've left a pile of data from 2011 on your desk, you can enter it into your data and rerun your syntax and get your updated results. Continue on your day. And you want your structure to be easy to navigate. So someone can find what they're looking for in your files with a reasonable amount of information. And if things are more complicated, I would recommend doing like an instruction document outlining where all your pieces are and all those pieces. But it kind of just depends on your situation. Okay. So talk a little bit about your iDrive folder structure. So if you have been thinking, you have a folder called data, you want to always keep separate folders for your raw data, your final data, and your syntax. And you want to keep your raw data in as unmodified format as possible. And your ability to modify depends on your data source. Some places don't allow you to do modifications in different stages. And yeah, but the importance there is just that you always can go back to that raw data. So if you've made a lot of changes in your raw data, and then you realize later on that, you know, I shouldn't really have done that because that wasn't such a good plan. If you don't have that, then you can be in a lot of trouble. Whereas if you have your raw data, something goes wrong later on, or you discover, you know, that assumption that you thought was correct really isn't, you can always go back to that. I always like have that. And if you're making changes to your raw data files, you can use a data correction log. And here's an example of the data corrections log. And I took out all the data because it had actual data in it. But you have your ID number. This one has ID number, instrument, question number, and wave, which are sort of particular to this project. But you want to have your original data, your corrected data. Those are the main important points. And then your date corrected and who you corrected it. So that if you're looking at something and it looks weird and you're going back, you know who to ask about why is it looking weird. And then you can do a tracking syntax if that makes sense for your project. Again, I took the data out of here, but probably didn't do that. This is the one for the SIPS project. So there's multiple people involved in that project, so every time I run this syntax, I put the date that it was updated in here. so someone else can take a look at it and know when the last time that that's next run and how kind of fresh the data is. And if that's, we want to update it again, or if that's going to be good enough for whatever purpose that they're using it for. Okay. And then in your data folder, you can include whatever other folders make sense. Typical ones, like for sieves, we have scales, contracts, and tables and documents. I think the waiver has like output and data sent. That's whatever kind of makes sense. I think the key is that you keep your raw data and your final data separate, and then you want to have a folder for your syntax because you're tracking everything you're doing. Those are the key things, and then everything else kind of just whatever makes sense. Okay. Okay, so I'm going to open SPSS now, and there was an issue with when I came in. There was a little issue with the computer has a couple different versions of SPSS, so it's already open, but it's not that exciting opening SPSS. So when you open SPSS, what's going to open is your data window, and that looks like this. And then this is the syntax file that I've created for this information. So what we're going to talk about first is when you first open a syntax file, you should always start with what I call the header information. So that when opening the file, right away can see kind of what's going on and what's going on in the file. So you're going to start with your researcher name, and then a little bit about your procedure, and that can be sort of, it depends on what you're doing. Like this is pretty simple, so it's just a couple words, but if it's more complicated, you could put a paragraph, and it kind of just depends on what makes sense for the procedure that you're doing here. You always want to put in who created the file, so that if there's ever questions later, you can always know to go back and ask. And the projects, and then the inputs, and so those are the data sources that you're using in the file, and then your outputs, which are your files that this data file is creating. And then you want to put the date and the data type, and the data type sometimes depends on what's appropriate for your project. Okay, so, and then as you're working in your syntax file, you want to include notes as comments before all the things that you do. So you want to, before you do something, you want to say what it is that you're doing, and sometimes you want to say why. It depends on what you're doing. So to write a comment, in the SPSS, you're going to put a little star, and then you're going to write your comment. And when you run the syntax, SPSS knows to ignore that part that's got the star in front of it. So it's going to go from your star to your period. If I took this period off, then it wouldn't run that piece. It would think that that's still a comment. Does that make sense? Okay. Okay. So that is general application stuff. Okay. So we talk a little bit about general SPSS notes, and I think I'm gonna run this get file first because I think that will make more sense. So your syntax window is basically where you do things. You import your data file, and then you do things to your data file to get answers to questions that you're looking for. So, okay. I'm gonna open this one. So in order to, so you write your commands, and then in order to run them, you can hit this green button, which is run selection. You can also go up here and do that. It's the same thing here. You can run the whole thing, which would run everything in your file, which we're not going to do today, but sometimes that might make sense. So if we hit this green button, then okay. We hit the green button, then our output window tells us what we did. It says we got this file. And then when we look in our data editor, there's our file. Okay, so I put some variables in here just for the examples. So the datasheet files, that's these files, they're going to have a .sav extension after them, but they don't have to. Because SPSS run that way. But it's generally a good idea when you create data files to give them the .sav file extension after them. But again, you don't have to if you want to have a different system. You can. I think it's easier to stick with that. But when I worked at OSLC, the convention there was to do .ra1, those are your raw files, and .da1 were your final data files. So you can come up with a different system if that works better for you. It just depends on what you want to do. Okay, so the other views, this is going to tell you what you did. It's also going to give you errors and warnings and other fun stuff if you've done something that doesn't like. But the thing about sometimes the errors and warnings are pretty clear. Sometimes they're not clear as far as what you've done, and we'll kind of see that as we go through. I built in some problems in the syntax that will give us some errors, and we'll have to go back and fix them. But one thing to keep in mind is that SPSS is it's a computer language, so it doesn't know what you want to do, so it might run your command. That doesn't mean that it did what you wanted it to do. But it's not going to give you an error message. It's going to say, sure, I did that. And then when you look at it, you're like, but that's not at all what I wanted. So that's something to remember. And then the other window, that is called SPSS. That's your syntax file. That's the extension of this file.
Sarah, so why does that happen? Like that it doesn't run what you ask? I mean, what does that mean? Like when you say it's a pure language? Like,
yeah. So, okay, let me think. Think of an example. So it's trying to think of an example that doesn't involve. So it's like if you, okay, well, this is an example. So if you ask for something, it has to have things in its formatted, and you have to ask for it in the right way, or it won't give it to you.
okay.
Do you know what I mean?
So I guess, so basically you think you've asked it
Yeah.
to do one thing, but because you haven't put something in the right boxes or whatever
right.
Okay, I see.
So okay, so if you think of it like a language, like if you say, you're writing a shopping list and you put, chocolate and then you put milk on the list. So if you have to format, like if you think of it that way, like, so does that mean that you want chocolate and milk, or does that mean that you want chocolate milk?
Okay.
So you might think, this is my list and I want chocolate and milk. But someone else looking at it is like, oh, they want chocolate milk, so that's what they get you. So it's kind of like that.
Okay.
Like you have to make sure that you're giving it, format it correctly so that it doesn't know what you want. So it'll kind of assume based on its kind of rules what it thinks that you want.
Okay.
Does that make sense?
No, that helps with the chocolate milk. Actually.
Okay. Okay, so, go over these real quick. So, when you open your data file, you can view your data. This is just the data that I put in. You can also go to what's called the variable view in the corner and switch. And that gives you an overview of your variables. It gives you their names, their types, their widths, labels and values and missing, which we'll get to later. So you can kind of see, you see the detail about your structure and your content, basically. And there are a lot of different menus. Mostly I don't use many of them. The one that I sometimes do use is the variable. So you can also view that same type of structure information here, which is sometimes helpful. You can kind of look at stuff like that. Okay. In your syntax menu, mostly what I use is run or again, you have variables. You can also look at cases. You can go to different things if that's useful. Helps you out there, and then your standard stuff, which is your save and your write and your undo, etc. Those are most of the things that I think you'll probably use for data management. Okay. Okay, so when you're writing commands, so here we're going to kind of go through these. Your commands can modify your variables or they can just display them in different ways. So you have a question that you're asking. Sometimes you just want to display things. Sometimes you want to modify things. Because those are two things that it can do. Placement of periods and quotation marks is important. So these pieces are important. It's important to have that piece there. And it's important placing your period there is different than if you place your period here. So the placement of those little things are important, but it's not a case sensitive, so your capitalization doesn't matter. As far as like your variables, you can run them any way you want to. And if you're doing a modification command, you can start the command, but it won't finish until you run you have to do an execute command to get it to finish the transformation. And we can go over that later. And SPSS gives you some indications in the text, whether or not you have errors or comments or things like that. Let's see if I did anything like that here. I think that I did. Okay, well we can go over that later. I think that'll make more sense to me. Let's see. Okay. So let's talk a little bit about data types. So data types are what you view when you're in the variable view. You can see what type of variable you have, and the three main ones are the date, the numeric, or the string variable. You can kind of see here, and then you can also see your width. You can also look. You can see here. You can set things here, and there's a bunch of different other options. But you might use restricted numeric, but I've not used these very much. But they look very exciting. If you want to use them, you should go for it. Okay. Those are the 3 ones. Okay, so let's talk about reading data into SPSS syntax. So, if you have a data file, you want to get it into SPSS. The command that you need to do that, it depends on the format of the data file that you're working with. So what we did first, we just did a really simple opening of the data file. And do that here. And there are other options that you can do for different types of files. See if you wanted to read it in an Excel file. So here's an Excel file that I've created. And I need to give it more information because it's not an SPSS file and it doesn't really know what's going on. So it needs more information. Some of the additional commands that it needs are, it needs to know what type of file that is. If it's, this is an older Excel file and this is a newer Excel file, so it looks a little bit different. It needs to know what cells that you want to pull into it. So in this example, I just want all the cells, whereas in this example, I just want a range of cells. In this example, there's a sheet that I'm going to pull from. Let's see. So in this example, the first row is just your instructions for data entry, so you don't want SPSS to pull that data in because there's no data there. So you're going to tell it to start here. You're going to say, I want to start at box A2 and go to box T7. I'm going to start here. I'm going to go here. You're going to tell it that you have names at the top of your data file, so you have it read names equals on. And you're going to tell it that you want to pull it from the sheet that's called list. And so that's the sheet here called list. So you're going to tell it all those things so that it knows that that's what you want to do. And then when you run it, it just gets the data that you want and ignores all the other stuff that's in your Excel file. And if you're doing data entry right to an Excel file, you can do you can put a lot of notes and instructions and colors and different things, which can make it easier for people as they're entering data.
So why did you have to have the execute after that one, but not after the other ones?
You know what? You actually don't have to have the execute there. I just put the execute there because okay, you don't actually have to have that. Not in this.
The period up above it is enough. That indicates, okay.
Yeah, when you're running a gap file from that, yeah. So then, there's that. Okay, so you can drop or keep errors when you open a file. So in this case, we can run this one and there's a keep, and I just want to keep 2 variables in that example. So let's say I don't really care about all the other data that's in there. But right now, I just want to know what their ID number is, if they're a cat. All I care about today, so I can just keep those 2 variables, and then you can pull that in. Your original data file remains unchanged. But what you've done is you've just created this temporary data file, which you have to save if you want to keep it as a permanent data file. But for right now, you can just look at those 2 pieces. And that's useful sometimes if you have like a ton of variables and you just don't really want to do all of the crap. You just want your one thing, and then you're going to get on with it. SPSS syntax can extract data from some databases with SQL. And there are some other options that you can do through your opening your database. There's some other things you can do, but I'm not going to go over all that stuff. today. Okay. All right. Does anyone have any questions?
I do.
Yeah.
You said periods and quotations, the placement is important. What do you use the quotation marks for?
So
Because I've seen them, but I don't know exactly what they're
yeah,
doing.
so it just sort of so you just put it around like your data file. You just put it around your data file. It just sort of contains. That's just kind of like the language that it wants. It wants you to put that on the beginning and the end of your file. It denotes that your file is starting and ending.
But only around the file, not around anything else. Quotation marks.
Sometimes for other commands you do use that. So if you're putting on a label, you'll use that. And if you're putting on labels or values, you also use the quotation marks. Those are that's pretty much the only time when you're applying things like that. It kind of denotes like a start and an end. Any other questions? Okay, so I'm going to run through some formatting commands, adding labels and values and missing values, and doing a couple other things that are a little bit more involved, but not. This stuff is all pretty straightforward. If you're downloading your data from a program like Qualtrics or Teleform, when it comes in, it might have some labels and values, and I don't think it would have missing, but it's possible that it might. You always want to check those because they may not be what you want them to be or what you expect them to be because of the ways the different programs set things up. And Qualtrics I think it looks at the way you formatted things on the screen, so sometimes it will and sometimes it won't, and it seems kind of random when you're looking at it in the data, but it probably makes more sense when you're building your survey. Because if you put some text at the top, sometimes it won't do things, whereas on the next question you don't have text at the top, and it does what you would expect. So it's important, even if you see that that's there, to always check and make sure that it's what you want it to look like. Okay, so we're going to get our file. Like that. That's okay. I'm going to clear out the output and just delete all. So the output kind of keeps a running log of what you've done, and depending on what you're doing, I tend to kind of clear out my output and then keep going because I usually do a lot of different things throughout the day. Some people will save outputs and then use them. I don't tend to do that, but you can do that if you are running different tests. It might make sense. I tend to, if I have something that I'm interested in, like to copy it into Word or Excel and edit it there. So depending on what makes sense to you. Okay, so we're going to add some variable labels, value labels, and missing values. Okay, so you select it and you run. And when you're giving it commands telling it what to do, it will go from the start to the period. So you can do that or like that, and it's the same thing. So then if you look and see in our variable view, you can see it's attached these labels here. You can view them in here. You can view our values here, and it doesn't matter. You can only see one, but you can view it. You can see the rest of them here if you open the box. And then here is where we applied some missing values to these two questions. And then if the answer is a 9, we count that as missing. And so sometimes when you're filling out pieces of data, you'll designate like this is a missing value. And so you're just telling it that it's missing. We don't want to count it. Okay. So I'm gonna do like a really simple compute command. So what we're gonna do is we're gonna compute the total of these three questions: question 1, question 2, and question 3. And there's question 1, question 2, and question 3 right here. So we're just gonna get the total of those, and we're gonna run that. And there's an error. So it is, this one actually, I think is pretty clear. I've also used this for a long time, so maybe it's not clear. So what it says is that one of the operands for the arithmetic operation is other than a numeric variable or numeric expression. So it will only add things together that are numeric types of variables. So you can't, within adding, you can't add like your name to your whatever you were adding it to. You can only add things that are numeric variables. So we want to look at our data here, and we can see that question 1 is a numeric, question 2 is a numeric, but question 3 is a string. And I've noticed this sometimes happens with Teleform or Qualtrics data. You might have a bunch of questions and they all look the same to you, but for some reason, one of them will be a string and they're all numerics. All the rest of them are numerics and one of them is a string, and you want to add them all together. And you can't, because for some reason it's decided that one of them is a string for some reason. And I'm sure it has a reason, but you don't know what it is. So, in order to change that, you're going to alter the type of this question to be a numeric. And we're going to give it 1 space and 0 decimal points. So we're going to run that. It's going to tell us this is what it was before, this is what it is now. If we look at it in the data, we can see it's now numeric. If we look at it in the data, we can see that it's a numeric and it doesn't have any decimal points in it.
So Jade, can you explain why you would do that in the syntax instead of in the data file itself?
Yeah, so you do it in the syntax because, so let's say that you're updating your Teleform data and it's a continual process. So every month you update your new file. So this way you can just run, every month you run your syntax and you don't have to go back and do it again. You don't have to, this is a lot faster. So you can just run your syntax, it does your fix, and then you kind of move on. You don't have to do things manually. You don't have to remember, okay, I have to stop, I have to go here and make the change, I have to come back. This way it just does it everything the way that you want it to do. Also, this way if someone else is coming back and looking at the file, they can see what you've done, exactly what you've done, instead of kind of like, well, now it's working, but it wasn't working before, so they must have done something, but I'm not really sure what they did or exactly how they did it. Does that make sense? Okay. Okay.
Sarah, is it like access that it saves automatically, or, and when you save it, is it like saving your original data file?
No. So it doesn't do anything automatically.
Okay.
Yeah. And so I was saving the syntax file. The data file isn't saved until we run the save command later. So yeah, so that's an alternate. This is a format. So if we look at our date variable here, it looks like that now, but we can make it look differently. You can format it like that, and that looks a little different. If you're having if someone's entering data right into the sheet, you might want to format it differently. It's easier for them to enter it. Skip that. So this sort cases command is going to sort the cases by ID number. As you can see right now, they're not totally in order. If we do the sort cases, then that's going to put them in the right order. Okay. I was going to talk a little bit about naming conventions, but I think I'm just going to skip that because this went a lot faster when I did it by myself. So I'm going to skip that. I think I'm also going to skip this one. So this is similar to about creating a data sheet with syntax, but I think we can just skip that one. So I'm going to skip those ones and go down to transformation commands. So these are examples of commands that you can do that will transform the data. So make changes in the data that are not structural, that are actual data changes. So each person who listed in the file has a staff code associated with them. So let's say your staff code is a 1 for employees and 2 for interns, and your 9 is your graduate students. And so that's why you set it up. You decide that you want to put your graduate students in with your employees. So you can just run a recode, staff recode, 9 equals, all the 9s are going to change to 1. Can you run it? And they're all. Okay. You can also do renaming the variables. So you want to rename your name to staff name because that's just better and it's clearer for you. You can run it, and then it will rename it to staff name. Okay. You can compute new variables from the variables that you have. In this example, I just did creating a year's variable from taking the months and dividing it by 12. So here are months, and here are years. You can use multiple variables or different functions when you use the compute command. So another way to create variables is to use the if command. So in this case, we want to create a variable called time, and all that we really care about is whether it's less than or more than 2 years. So we're going to say if the years are less than or equal to 2, it's going to be 1, and if they're greater than or equal to 2, it's going to be a 2. And we're going to put some value labels on it. And then there's our variable. There's no data because the transformations are still pending, and if you look down in the corner, it'll give you that message here. And so I'm just going to pick executes and click on it. And then it's going to pop your data in there.
So how do you know when you have to do execute and when you don't?
If it tells you the transformations are pending, you just put an execute on there. Sometimes it depends too, like as you're writing things, you might know you want to do a lot of different things, and then you just run it all together like we did before, and then when you do one thing, it will automatically do that when it moves on to the next piece. Does that make sense? So if I didn't have the execute here, but I run this and then I run this piece, the start of this will finish that first piece.
Okay.
And so if you're doing a bunch of different things, you don't always have to have all the executes. It kind of just depends on what you want it to look like. Some people like to have the executes. Some people just find that it kind of clutters things up if you have too many executes, and if you don't need them. And sometimes it doesn't always make sense to me. Maybe I'm sure it makes sense to other people, but if I'm not sure, I'll just put the execute in, and then you're kind of safe. And if you didn't need it, it's not really that important. And it just kind of depends on how you like things to look.
Does the execute group certain chunks of your data that you're running, or does it just there? Okay, I don't understand. I guess.
Yeah. So what the execute does is it kind of like, example. So it's like if you have something in your it doesn't really group things. It just kind of pushes. Like if you run one command and you run the next command, it kind of pushes it along.
Okay.
Kind of like if it's on a conveyor belt. Like if you ask for something, but you ask for something else, it has to push that along because it only has enough space to do the piece.
Yeah.
Okay. Does that make sense?
And so it's not like, oh, sorry.
No.
So it's not like in Word, if you put in page breaks, then you go to number and then it messes that all. It's not like that. But
No,
now I've
no.
stuck execute, so it's only going to do the same.
Mm-hmm.
Okay.
I was just gonna ask, do you have like a code book or something that's giving you the like abbreviations for less than and greater than and all of that, or do you just know that from?
I think yeah, you could probably find those ones in the there probably is somewhere in the SPSS documentation that has those things. There's not really that. I mean, you can use less than or equal to, greater than equal to. You can also use the
Symbols.
symbols, but I always get confused by the symbols, so that's why I don't use them. Because I'm always like, then I always have to do this. Then I anyway. Yeah, I have to go over my But there are some basic commands, and there's probably a sheet somewhere that exists. Yeah, you can Google it. You can probably find it. You can do less than, greater than, or equal to, less than, or equal to. You can also do through high. Sometimes you want to just like say you asked people like how many cigarettes they smoked in the last month, but you look at that, you really don't care. If you just want it to be like smoker and non-smoker, then you can say, 1 through high equals 1, because I really just want like non or 1.
Yeah.
So there's some other little things like that.
Okay.
But yeah, I don't really know of like a good resource for that.
So you just learned it.
Yeah, I just kind of picked it up over time.
Okay.
There's some stuff on the help menu, but there's also a ton online. You can go searching if you know what you want to ask SPSS, you can usually find it.
Okay.
Not in talent.
Some of it is in prompt. She's getting better at putting syntax. Not necessarily her book.
Any other questions? Okay, so this isn't just a simple if command that would account to everyone. You can also use do if command. And so in this example, so in this question, the way the data is set up, the lead question is, are you a cat owner? Which is a 1 if you're a yes, and a 0 if you're a no. And generally for yes or no variables, it's better to use a 1 for a yes than a 0 for a no. And that has to do with other stats things that we're not talking about today, but it's simpler later on for people that are doing analysis when they're working with data. So it's kind of a general convention that you see a lot. So for this question, it's like, so if you didn't have a cat, then whether you had a Persian or a tabby, it's just blank. There's no data there. And that is called a system missing variable. So variables can either be system missing, which is mean they're blank like this, or they can be, you can define something as missing. So if your scale was like yes, no, or a 9 would be you don't know or refuse, then you would have to define that as missing if you want variable. So in this case, this is what I did with my data, but I want to recode that because I just want to know out of everyone how many people have Persian tabbies, regardless of whether or not they're cat. So I can say if cat is 0, then I'm going to recode the Persian and the tabby. If it's a system missing, then it will become a 0 as well. And then I have to do an end if command and then do an execute to sort of end that structure. So we'll run that. And that fills in, if it's a 0, it fills it in here. But it doesn't fill it in if it's not, if it's just completely missing, then it leaves it. Okay, I will do this one real quick. Or maybe I won't do it. No, I'll go ahead and do it real quick. So this is a command that actually creates a new data file. It's an aggregate command. So what this command is doing is looking at, often a question that I want to know when I'm looking at the data is whether or not things like this where I have one person, what ID number has two records, because often that's a mistake. Not always, but depending on your situation, often like I want to know that because that indicates that there's a problem if we're having like more than one cases. So this piece of syntax will aggregate your file. So it's going to create a new file based on your ID file, and it's going to tell me how many records in this file each ID number has. So it's going to create this new file, and then I'm going to get that file. I create it, but I don't get it. I'm going to keep working with the old file.
Does that make sense?
And then I'm going to list out what I'm going to do is what's called the temporary selective, and I'm going to get a list of all my people, of all my ID numbers where they have more than one record in that file. It's going to look like that. I'm going to come up with a list of 7. And if I look in my data, it's telling me that person number 1 had 1 record, person number 7 had 2 records. So I know that I need to take a look and see why that happened. I think it's like when teleform it happens when you're scanning in, sometimes it's hard to keep track of different things. So that's sort of an issue with teleform. It's not something I find that's not true with other things like call tracks because it's just not just the structure of how that process works doesn't make sense in the data. Okay, are there any questions? Okay. So it's already. Did I say 10:30?
You did.
Okay.
I think we might have said 11 in our earlier announcement. I'm not sure what.
Okay. Sorry, it's taking so long. I can just let me see. What else do I have? I don't have that many pieces left. I just go over this piece. Well, yeah. Okay. Maybe I'll just keep going if people have to go. Okay, it's fine. Okay, so the next thing we're going to look at is looking at your data, which is important to tell if your data looks the way that you want it to look and what you're expecting it to look like. So I'm going to get that file again. So because we didn't save the file, it doesn't have any of the changes that we made. So this is just getting the file view again. So the first thing that's super simple is you can do a frequency virus equals all. So you just look at all your data, see everything that's in the file, and what does that look like? You can run that, and it's going to tell you your frequency virus equals all. So it's going to tell you for each variable kind of what the breakdown is. So for your date variable, it's going to tell you what the value is and how often you see that value. And it's going to give you percent and then valid percent, which doesn't matter here, but it'll matter later on. So you can see that 2 of these were done on December 12th and etc. See your ID numbers here. If you were looking, this is another way that you can see with a small data set, it's really obvious who has more than one ID number. If you have like a larger data set, then this can be like hundreds of records, and so looking through each one isn't really what you want to do. But you might want to look at this more just to make sure that everyone has an ID number, because that's really important. If someone doesn't have an ID number, then that's a sign that you get some problems. That's your name. Let me do our stock code. This is a one that I created called number. And this is called string. And so you can see there's some missing data here. And that's okay. And so it's missing data and it's system missing data. So that means that there's nothing here. It's missing in that piece. And so it will give you the percents both out of your the data that you have and out of everyone. So you can see that out of everyone, 33% answered one to this question. But if you're looking at just what you call your valid percent, that's just people that are not missing, then that's a lot higher. And depending on the question that you're asking, you might want to look at one or the other. It just kind of depends on what's appropriate for your question. This is an example of a string variable I created, and it's one of the reasons. Let's see. So it's one of the reasons why it's preferable to use numbers rather than text, because as you can see here, it's giving you, because the person typed this in a little bit differently here, it's putting them on separate lines because it doesn't know that they're the same thing. It doesn't know that a y with a small is the same as a big Y, it just knows that they're different. And so it's going to put them on a different line, which is probably not what you want. Strings also don't give you the options of the percent and valid percent, it just does the same.
So then strings are like case sensitive, or like if you.
Yeah, so they're
Okay.
just text variables. They're just any
Okay.
text that you want to enter. And sometimes that makes sense. Like if you want to ask someone like a question, like let's say that you were doing you're doing a survey and you're asking someone like about how they feel. And so you might have like some questions about like, are you happy on a 1 to 5 scale? Were you sad on a 1 to 5 scale at the end? You're just general comments, which might make sense, and that can sometimes help you like determining what's going on in the other questions. But it's different. But it's just whatever people enter. Does that make sense?
Okay.
This is a different type of variable.
Okay.
Like I think have you used Access? You used Access before, right? And it's the same in Access. So you have different.
Yeah, there's text versus numbers.
Mm-hmm. Yeah. Okay. So this is my. How did I change that? So this is an example of trying to get more than one piece of information in the variable. So if we're doing, so this is an example of the way that you'd like to do it, which is your school is 1 and your employment is 1 case, and then you enter 0 and 1 for your different options. This is a bad idea because as you can see, like it's really not clear. And when you do your frequencies, if you want to just know like how many people have a job, you can't tell that from this. This doesn't provide you with the information that you need. And so you'd have to reformat it to look something more like this. You'd have to manually go through and make it look pretty, which we always want to avoid doing things manually because that's when mistakes happen. Then you get one set of numbers and someone else comes along and does it later and gets a whole other set of numbers. And then craziness ensues. Okay. Yeah, okay. I think so. You can look at all your variables, but you can also just say, I'm really just interested in this variable and that variable, and that's all I want to get. So you just run your frequency table, and you just get this variable and that variable, because that's all I care about right now. The other way you can look at the data that makes sense for numeric is you can look at what's called the descriptives. And this just looks at the descriptives for all the variables. And it will tell you how many people are there, how many people are present, your minimum, your maximum, your mean, and your standard deviation. And it will give you a warning, and it will tell you that it's not going to give you descriptives for string variables. And sometimes with some things, it's a little weird, I think, that there's a warning and an error. So it will say, like with this example, it'll say, I'm not going to give you those ones because they're strings. I'm not going to look at that, but I'll do everything else. Or sometimes it'll just say, I'm not doing anything else. You don't get anything. Yeah. And you can see your warning will also pop up right down here. You can see it there in that window. You can list all the variables, but that's not really useful, so I'm just going to do this one. So you can list out your ID. So in this case, we're listing out our ID and our school variable and our employment. Maybe we just want to get a list of that and compare it to. That's whatever we need to compare it to, or we just want to look at it. Maybe we want to look at it because if you know data really well, you might want to look at it and say that's not true or whatever. You can look at it. You can use the list to kind of look at it that way. Another option that you can do is a report format, and that is basically a list, but you can add labels onto it, so you can look at the data like this. So you add your labels back on because we didn't save them, so they are on there. And then you can look at your ID, your date, and then your label that you put on that value. So that might be more useful if you were going to give it to someone else, or it might be more useful for you. It just depends on what you want. So you can say this person said they were employed, and then and you can use the temporary select if command, and that will allow you to look at a subset of data. So it's a little complicated. What I did here is, if you wanted to just look at cat owners who are missing the school variable and have a valid date, then you can get that list, and it will just give you that one person. So you can do that however, whatever you. So if you just want to get cat owners, you can just get that list. Tell it kind of who you want, and then it will just give you that. And it's a temporary, so it just applies to that one command. And so then you just keep.
So if you hadn't put the temporary, then would it work from that smaller thing?
Yeah, so if you hadn't put the temporary, then it just takes all your other data out, and as you keep moving forward, then you just don't have all that data. Yeah, that's a generally selective. We'll just do that. Which sometimes you might want to do that if you're working with your data, but you want to make sure that's not what you do. Because if you don't want to do that, you want to keep a full data set. You want to make sure that you have the temporary. Okay. So, should we keep going? Or is it like, are there any questions now? Is it like, do you feel like your brain's full, or should I keep going?
I want you to keep going because I want to see it. I don't know if my brain's going to retain it all.
Okay.
That's kind of a different question.
Okay, I'll just keep going. Okay, so we talk a little about adding and then saving files. So sometimes what you want to do is you want to put two files. You want to match two files in together. So let's say that you have data in one place that's talking about, let's say you're doing a treatment and control study. So you have data in one file that lists like whether the treatment or control and how much treatment they got or something like that you're keeping in one place. And then in another place you have data that's talking about how well they're doing in school. And you want to mesh those two files together so you can see if your group is doing better or worse or what the difference is. So you want to put two files together. So you can do that. I'm trying to remember.
Do you copy and paste?
Copy and paste? Yes. You're your friend. Yes.
I'm just asking because I've seen people do that.
Mm-hmm. Yeah, so you would copy like your file name and you would put it in there. So when you're matching your two files in, you can tell it that you want to take the file that you have open right now and then match it this new file here by ID number. So in order for that to work, the files all have to be in order. They all have to be sorted in the same order by your ID, by the variable, by your matching variable that you're going to use. And so I'm trying to remember what I did. I wrote something with mistakes here, but let's see if this is the one that I wrote with mistakes. I don't remember. I'll clear that up. Yeah, no, I wrote this one with mistakes. Okay. Let's skip this one up and let's leave it. Let's see what I do. Okay.
Pilot does have a section about matching data files.
Does it?
Yeah.
Is it, I have
And
a
there
really
is some
specific
do
question.
commands, I think, or if commands as well, but I mean, she kind of keeps it pretty basic on this.
Okay. I was a very specific question for you. Is this,
Sure.
so in the My Life data, I'm
It's a
wanting
book
to
that's
use
commonly used in the school social.
the outcome measure and the YSR, but only
Okay.
certain variables from those.
Yeah.
And
And it's written by Julie.
I was wanting to
Okay.
use, data that Jessica used for hers, and so there was ID numbers that are in the YSR that aren't in that, and so is this an example of syntax I would use then to match those up so that I have the same ID numbers in both that I want to use? So if there's, okay, so it would take out all of the variables from, it would take out all the ID numbers from the YSR if they don't match the file that's there that Jessica was using. It doesn't have all the ID numbers in it. I don't know if I'm making sense.
Yeah, no, I got you. Okay, so you can do that. I mean, so if you have one file and the second file,
Mm-hmm.
you add them in. It's going to keep everyone in like the general match file. It will keep everyone. If they're not present, they'll just be missing for those variables. You can remove them if you have like a you can remove them with like a, I'm trying to think.
I don't mean to take you away from what you were doing.
No,
I just want to make this.
You can remove them with a selective command, like, so probably what I would do is I take my first data file and then I would just create like I would just do like, I'd create like a temporary file, a temporary variable that would be like, what were the files you wanted to do?
The outcome measure and the YSR.
So I take my outcome measure file and I create a temporary file. I create a temporary variable. I say outcome measure equals 1. And that's going to give everyone in that file. It's going to have a 1 for that variable. And then in my second file, I would create a temporary file called the YSR equals 1, and then put that just for that data file, so that everyone in that file has a 1 on that. So you want the ones that have both.
Yeah.
So then you'd match them together, and then you'd say select if YSR equals 1 and file equals 1. And then it will pick everyone out who doesn't have a 1.
So much easier than going through and deleting the ID number because they didn't match.
Yeah.
But if you did the match thing, you'd have it, but you just have, you know, ones that have the outcome would be on the line, and then the ones that have the youth would, you know, be on the line.
Right, yeah.
So you could still use that data file to just do this match thing, but you'd have the ones that have one of the other, not necessarily.
Okay.
So
Yeah.
But then I can go in and create syntax to do what you said and just take the ones that have both.
Yeah.
So much easier.
Yeah. In order to do that, they have to be sorted in the same order, and your ID variable has to be the same. It has to be the same type, so you can't match a text. They have to both be numeric if you're doing a numeric, which I don't know if you are. Is it?
I think all the IDs are numeric.
Okay. They have to be numeric, and they also have to be the same length.
Okay.
So if they're not matching up, that might be because your width is not there.
Okay.
But yeah.
I didn't know how to match them up, so.
Yeah. No, but you and I can talk later.
That'd be awesome, actually. Yeah.
Another option that you can do sometimes, you just want to add files together. You might collect some data for one period of time, you put it in one file, and then maybe at your first cohort, you put in one file, your second cohort, you put in another file, so you just put all your cohorts together. And then it's basically the same type of thing. You're just adding the file. This one adds a value of now to 2 and 3. And I think this might not work though because, it does work. Okay. Yeah, and then it just adds it. So Because it's the same thing, it's just adding, it's just gonna keep going, and if it's missing, it's just, if something isn't present, it's just gonna be missing, but because of the structure, this is adding the same thing. Does that make sense? Okay. And then, if you want to save your data, so you made a bunch of changes, you want to save your out file, then you just run a command that's save out file and then your data file name there, and then it will just save it. And it's going to create a new file right here. We just created that file right now. And then you can go back, and your original file is going to, so our original data file is going to look exactly the same as it did before we made all those edits. And everything that we did, that we edited, is going to be in our new file. Okay. And then, let's see. Okay, and then this is just some really simple, I did some really simple analysis. There's not any statistical tests, we're just going to look at some means and crosstabs. And so we're going to get our file again, our old file, and then we're going to look at the means of our month variable. And so we're going to ask for the mean, the count, the standard deviation, the minimum, the maximum, the median. And you can change this list depending on what you want. If you decide, I don't really want the median, then you just take the median out. It'll show up in the list, in your list of variables. So that's going to tell you your mean, your count, your standard deviation, your minimum, your maximum here of those variables. It's also going to tell you up here how many were included and how many were excluded out of your total. We have 6 people in our file. 2 of those people are missing, so they're going to be excluded from that analysis. And you can do as many variables as you want with one command. So we did 2, we did months, and then our other variable we just call number. And so it's going to tell you all that same information, just it looks a little bit different. It's kind of, you can see it like that. And you can use a by variable to look at your data by, to give you the means and different statistics by a variable. So this is going to tell you of the people who are not in school and then the people that are in school. So you might, that might be an important difference for you. Are people in school looking different on this variable than people who are not in school? And then you can also use the temporary selective to look for just a set sample of folks. So if we just want to look at cat owners, we can do that. And there are only 2 cat owners, so there's no standard deviation. There's only one. There's only 2 cat owners, but only one of them has that variable. So there's no same thing. Does anyone have any questions about that? Okay. I'm going to clean this out. And then the last thing is to run some crosstab tables. And so we're basically going to compare 2 variables and see how they look when you're looking at the 2 groups. So the first one is super simple. We're just going to look at the counts. So this is saying that of the people who are not employed, there's only 1 person, and they're going to school. Whereas the people who are employed, there are 2 people, one of them is going to school, one of them is not going to school. And you can customize your command. It can give you your column percentages with your numbers or your row percentages, depending on what you want to look at. So in this case, it's going to give you our column percentages. So of the people who are employed, 50% are in school and 50% are not in school. Whereas with these row percentages, looking at people who aren't in school, 100% of them are employed. Does that make sense? And then you can do a by variable on that one as well. Okay. So, are there any questions? There are some resources that I've used, and there is a ton of other resources out there too. UCLA has a really good website. Let's see, that if you go to it, can I get to it? Okay, well we can't get to it, but you have to trust me, it's there.
Can you just send us this?
Yeah,
Okay.
yeah, they have a really good website that has a lot of gives a lot of really clear examples. Yale also has one that I haven't used that much, but I've heard that it's good. There's an SPSS Google group, which are just random people from all over that like to do things in SPSS. And if you ask questions, they'll
Have them on their home computers.
Yeah.
They're rock stars.
And then me, so you can email me questions, and I am around and can talk, and you should email me.
I'm totally emailing you.
Yeah.
I'm like, oh, jeez, this made my brain so much better.
Okay.
So, I was gonna say, because that's, okay, so yes, I have this, I have SPSS at home.
It's like I admit it.
When I finished school, I wanted to be able to be fine with it, and I don't, you might know, but there is a website that's just a conglomerate of data sets, like little ones, big ones, that are up for public use. And it is something that I have personally used, where you just download the data set and you play with SPSS till your heart's desire and not screw up any of your stuff. So it's something that I've used. In class, I had my own stuff I was working on. You're done with class, so it's like, now what? To make everything, it's like, you could, but. So you could just, I'll see if I can find the website again, but you can also just look for probably public data sets, stuff like that, public SPSS data sets. And it's just a big website, and they have little ones, big ones, and then I use them with the SPSS, and you can just download it here and use it if you don't have it at home, and play with it, figure out how to do stuff without worrying and messing up your project and stuff. And it's like, you don't have to worry about what did I just do? But it's something that I found helpful because, and it gives you a little bit of a description about each one, so you have an idea, but you have some huge 1,000-case ones and some smaller ones, so it's really nice to be able to play and figure out how to do all that stuff.
Thanks.
Awesome. Thank you very much.
Yeah. And you can always, like I said, email me if you have
At least now you know if you do it again in an hour and a half.
Yeah, it didn't take that long when I was doing it. Thanks.